sorry मैं सिर्फ lecture recording लगा. So these standards are national standards. आपने देखे होंगे जो ज़रा broader standards होते हैं, WHO standards for example, that they could apply to multiple countries. कोई और standard ऐसा, I can't think of it right now, but let's say some standards are generic and they are for people to get guidelines. For example, USEF set some standards for environment. But जो उनके respective governments के या countries के वो होंगे ना standards, they would be made by their EPAs. So the standards that we have for Pakistan, which is by the way just somewhere in the middle of WHO and USEF, US government standards, is our national standard, and that's why we call it the National Environmental Quality Standard, or NEQs. I will be touching upon them today, but I think I'm trying to make that understandable for everyone. Because if someone is in the management, in the field of management, or let's say in the field of sociology, and ends up writing a report on human influence on environment, but doesn't know what dissolved oxygen is, or what milligrams per liter is, or all of those basic things, the next lecture, instead of discussing water policy, I'll try and discuss those terms. I would initiate it here, but I think we would just study them on their own today, and next time we'll take certain environmental reports, both social science related and science related, and I'll just, for example, show you one of my researches and how these parameters and those limits reflect in the reports, so that what does someone mean when they say the temperature of the water is increasing after an industry dumps its wastewater into the water stream, and you automatically know what they're talking about, especially if they say the DO decreased to 2. You should know that this is not a good sign, and you should know that DO means dissolved oxygen, etc., etc. So that was, but I will show you the NEQs today. I will not discuss them in great detail. I'll just show you what they are. In the annex slides, I've also attached, because the NEQs were recently upgraded, which means that it's not the same that I read, for example. So they've been upgraded for effluents, for air emission, for noise, etc., etc. So it's become broad, which wasn't true when I did my undergrad. So it's a good thing that it's evolving. So should we start the lecture? Where are all the other people? Okay, does anyone have any other question from last, or comment? If there was anything that you wanted to say with respect to any of the slides last week, if you think that you wanted to say it but could not say it, while I'm waiting for a few others, I can let you speak. No? So should we just start? All right. So why do you think, we discussed it slightly, but why do you think our law is important? Why can't we just be responsible on our own? Taiba?
Ma'am, I think that laws are kind of necessary to regulate. Leaving people to their own devices isn't really as smart of an idea, because some people will abide by it, but the majority probably won't. And there's like a major difference between, like, there's a lot of factors that come into play that lead to people abiding by a certain rules, and it's not enough just to state them. I feel like they need to be implemented. They need to be like actions taken against those who don't follow them, and generally like rules to make sure that people abide by the guidelines.
And why is it so difficult to think that people will not abide by them? Like I'm thinking in terms of the polluter pay principle, or something that Azhan mentioned last week, that people are selfish and they don't live in an ideal world, and we don't live in an ideal world, and that's why people wouldn't follow these standards. I mean, why?
May I answer, ma'am?
Was that?
Hamad.
Go ahead, Hamad.
So, ma'am, what I think which you mentioned, that people usually don't abide by the laws. The reason behind it is that the self-interest comes into play in this case. Like they would weigh the possibilities, and the one that benefits them, or that like you can say the कोई ऐसी पॉसिबिलिटी जिससे वो प्रॉफिट कर रहे हो, या रिसोर्स की यूजेज से अगर वो प्रॉफिटेबल हो उनके लिए, तो वो उसको एक्सेसिव यूज को अवॉइड नहीं करेंगे, मतलब सेल्फ इंटरेस्ट को ज़्यादा प्रेफरेंस दी जाएगी. दैट्स व्हाई वो रेगुलेट करना मतलब मुश्किल हो जाएगा, बिकॉज ऑफ सेल्फ इंटरेस्ट. You people usually don't abide by the laws.
Yeah, okay. I mean, right. तैयबा, आपको क्या लगता है?
It's also like people are only thinking about today. They're not thinking about the future impacts of like what these things could do in the future. So like it's a human nature, right? We are selfish by nature. That's like a human trait. So if you don't employ these laws, we're thinking about what we're gonna do today and not how we can help the planet in the future. Like people throw rubbish on the street because at that particular moment in time they don't feel like getting up and go walking to the trash can, even though it may be very close to them. But if this builds up, this can have very disastrous effects.
Yeah, Hassan's written Tragedy of the Commons. Yeah, I think that's why I wanted you to know about Tragedy of the Commons. It's just we think if we don't pollute it, someone else will, and that's why we might as well just do it. Or if we see our neighbor polluting it, we say he's doing it, why can't I do it? But I think this is a discussion that we will have slightly in the lecture that I've designed on environmental ethics, of where do we draw the line, and how do we expect for people or every individual to be ethical. Why are we in 2020 having this discussion that a polluter should be penalized, or that incentives should be given for them to care about the environment? These are never ending debates, but also sometimes they're disappointing that in this era of information technology and communication, we are not able to understand basic ethics of living in a planet that we share with many other animals and plants. Right. So I did this idea of introducing you to environmental law for me was important because I would at some point discuss the national environmental quality standards, or when we speak about water pollution, air pollution, I'll talk about certain parameters. I'll speak about the limits, that the limits need to be followed. But then you need to understand, how did they emerge? Were they always there? And before this lecture, it was important to tell you how the international laws have emerged, because they have expedited this process, the process of formulation of regulation on environment in our respective countries. So that's why it was important that we look at that. And then based on that, we have developed certain organizations and certain tools that would ensure that the environment is clean or is sustainable enough for all life forms that live on the planet. I wanted to start with a case study, which when we were taught environmental law, we were told that it was one of the groundbreaking cases that took place between WAPTA and Sheila Zia, who was also a lawyer, but mostly a women activist who fought for the rights of the women. In their area, WAPTA was planning to build a grid station. Now, we've studied electromagnetic radiations before. So this particular residents felt that because it was being done without information to them, my voice is breaking. Why is my voice breaking? Like, how bad? Is it very bad?
It is all right
It's fine here.
for me.
Ma'am, I can hear you clearly.
Okay, I think it's just you, Heather. It's just you. So let's hope that it's fine. Okay. So all right. And then, because they said that the electromagnetic radiations wouldn't be nice for us, they looked at all the international reports and they linked it to many other diseases. They put it forth to the High Court as a problem of non-communicable disease, where their right to live was being compromised on. It was dismissed by the government, the then government. They said, it's all right, these kind of projects take place everywhere. And then they had to go to the Supreme Court, and then the Supreme Court introduced the Article 9, which is the right to life. And under the right to life, they said that the right to life is not just about being born and dying. It's about living a healthy, happy life on this planet. And that's when all of these things were brought into account. And they said that the authorities would have to inform the public before they bring such projects or such interventions into action. And that's why, a public hearing or a notification that could tell the localities that such a project is happening became compulsory because of this case. So when we speak about actions, I think we shouldn't undermine the role of every field that there is. And this was one of them where, through this case, the law was changed. Sometimes through the law, certain things can be enacted, but also at times when a certain right or a certain law hasn't been established, when people ask for it, when negotiations happen, and the law bodies or the law enforcing bodies realize that laws don't exist on that, they would introduce something for it. Now, I want you to, because there was a mention of electromagnetic radiations being harmful for your health. How are they harmful for your health? Like, why, what harm do they do to us? Does anyone know? Daniel.
Electromagnetic radiations can harm the cells in our body and they can create cancerous cells.
And those radiations, what do they do when they enter your tissues? Like how much? So is it safe for me to sit in front of my laptop or my computer? And how long, like what kind of radiations generally are?
It would depend on the frequency of the radiation.
Okay. Hassan, do you want to add to this? You've also raised your hand.
Daniel is right, where like the frequency is important because most of the lower frequencies will not harm you at all. And one thing that I found actually kind of hilarious about the case that you pointed out, because I've read it, is that they pointed out that the electromagnetic waves were correlated to AIDS, which is actually pretty much nonsense. Because electromagnetic waves
related
to AIDS, HIV/AIDS.
Yeah.
And it made absolutely no sense to me when I read the case. So it was a little exaggerated.
Because none of that research existed on the ground, Hassan, and they were basically against the project. So they used all kind of information that was available, and some of that information may not have been relevant. And that's exactly how the government then responded, right? They said, this project is for the people, and we will go ahead with it. We are dismissing all of this, and that there's no ground to the facts that you've shared. It's just research by somebody. But then the Supreme Court went on to say that no, we need scientific evidence for such cases, and that it needs to be approved. Now they're both, we can look at them both ways, and I'm not at particular side. I'm not taking a particular side. But the truth is that, as you said yourself, that some electromagnetic radiations, especially those that are ionizing, that can break the bonds in your cells or in your tissues, and therefore damage or mutate the cell. So when we speak about cell mutations in biology, what do we say? That if there is a certain radiation that can cause for the bonds in the cell to break down or in the tissues to break down, it would mutate with the genes that are eventually responsible for healthy cell growth. So it's not that there are no impacts, but also at times impacts can be exaggerated. For example, a lot of people say that the impacts of cell phones. So I remember when we started using cell phone, there was a huge debate about how bad they are for your health, right? And then they could be causing cancers. But now a lot of people who are pro these gadgets would tell you that's ridiculous, because it's non-ionizing and you need a lot of exposure for that to happen, and actually the other ones are more dangerous. But it would be good for us to know to know this. And computers generally only release, I think, radio waves, if I'm not wrong. So it's not a big harm. But if you stay in front of your screen for a very long time, it could still cause some health impacts, maybe strain on the eyes, strain on the head. We don't know the long-term impacts, but there could still be some indirect impacts of certain electronic gadgets that we use. And maybe that grid station had it, some of the studies were actually scientifically proven around the globe and important. But I just wanted to put it there for you to know how one complements the other. And that was, I think, the first of its kind. And then from there on, now in the environmental tribunals, you see all kinds of cases which start from sometimes a scientific report. And this particular report by the IUCN stopped the Punjab government from doing a development project in the Murray Hills. So sometimes it's a happy ending, sometimes it's a sad ending. So whatever. But that was the impact of presence of law and how that affects it. Who is Dr. Samia Altaf?
Ma'am, by the way, I thought it's, she's the head of health and safety committee at NAMS.
Okay, I don't know her, so I'll leave it to her. Okay, yeah. So a lot of screen
time. The main purpose of commenting this is realize that we are using laptop or electronic devices, so probably nobody knows the impact that it might have in our life.
Yeah, ask your economics department to do a randomized controlled research that, what is the impact on your well-being, on your cells, how are they reproducing well, what is happening to your brain cells when you're using a lot of screen. Anyways, that debate is for another day. But we spoke last time about the certain actions that were taken using these laws and how they could protect our environment. And there are many principles around it. You read about the polluter pays principle a lot. I generally believe that you shouldn't go to the stage where someone is able to pollute the environment and has to pay for it. And I also at times question, how do you decide on the money, right? For example, in the case of Pakistan, the laws or the polluter pay principle is so old, it's like almost a decade or two old. How has that not been updated, and how does that impact the fine that you place on certain industries? And that's why I'm actually pro the precautionary principle, where industries, individuals should be encouraged or given incentives to be more cautious in what they do, so that they don't pollute as much. And they have more incentives when they don't pollute at all, instead of them polluting and then paying for it. So these principles kind of interchange. All of them were coined in the 1970s. I don't want to go into the details. I just wanted you to know about them. That you can use different principles: precautionary, polluter pay, or just recognizing the services that the ecosystem provides to you, which is the sustainability principle. But regardless, there's a lot of discussion on how do you value or put a value to a particular service, right? How do you decide that this is going to be your monthly bill for water in your house? That decision, I think, is very very important. So the difference between sustainability and precautionary principle is, in the sustainability, you're kind of just thinking more about sustainability. I have this resource, which is air, or I have this resource, which is land. I want for it to be sustainable. And I recognize the services that it provides to me. What do I do to make sure that it remains sustainable enough? Right? So that's that approach. But when you precautionary is more like, if I'm in industry, they are interchangeable in a way, but precautionary is like you take care, you are very cautious in what you do, whether as a farmer or as a top-notch industrialist. Whichever place you hold in the decision making, you make sure that you are taking all precautions necessary to make sure that the planet is not being harmed. And they also translate into the social principles on environmental, social principles to protect the environment. And we speak about the equity, the participation, and the human rights. Again, another reason for us to look at the SDGs and how it made it compulsory for local voices to be brought into picture is, again, a social principle that led on for environmental protection. When a community, an indigenous community that is taking care of a forest, of a particular area of land, was brought into picture, the entire story changes. These principles of participation and equality and human rights, or the right to life and the right to drink clean water and the right to live under clean air, they're all also very important in making sure that the environment is protected. And again, there again can be very economic methods, which is putting a monetary value to it, producing instruments for control, but also making sure that they are presented. How do you use, let's say, clean development mechanism or joint implementation, or the protocols for Kyoto to ensure that your environment is being protected? So there can be multiple approaches for you to look at your environment. Now, why was everything that we looked at in the previous two classes important? Because that led for our law, the law in Pakistan, to establish in the area of sustainability. Of course, we were very young constitutionally. In the 1973, we had our own constitution, and we had other things to worry about. Soon after we got independence, environment was not a priority, because our priority was to be economically stable, to make sure other things are intact. But after the 1972 Convention on Human Environment, or Conference on Human Environment, they came back soon after our constitution was present. Then a ministry was established, and past the ministry, first an ordinance was established, which was not as big as an act. And then after the 1983 ordinance, Environmental Protection Act was enacted in 1997. And between these, we formed national conservation strategies, we formed national environmental quality standards, we upgraded them, and we upgraded them in a sense that now there was something for the industry to follow. Now there were environmental laboratories that we had given them certain rules to monitor the sample, because people could send fake samples as well. So there were like more protocols for things to be more streamlined. And the triangles are my drawing, and arrows. They just show you progress over time. Right. And throughout these years, a lot has happened. So within the language of law, you would see that a policy, a law, an ordinance, a rule, a regulation, a framework, they all mean different things, and they have different kind of authority. So the apex legal document would be the Pakistan Environmental Protection Act, which I asked you to read as a reading in your class, which was established in 1997. It's kind of the same Pakistan Environmental Protection Ordinance that was formulated in 1983. It was enacted at a national scale. And so it became an apex legal framework for the entire country to follow. And under that act, we formed certain bodies such as the Pakistan Environmental Protection Council. We formed funds such as the Sustainable Development Funds that could be sent to respective provinces or the federal agency. We formed the environmental protection agencies, not only federal but provincial as well. So there was a system that was established to make sure that environment is being managed. And of course, a lot of other policies relate to it as well, like the education policy, the health policy. They're all somehow a part of your environmental policy as well, because they're also related to the environment. And then, you would see that there were a lot of other strategies and frameworks that came up. The most recent document, which is kind of another important document, is the National Water Policy, which was approved last year and has already been enacted. And like I said, the Pakistan Environmental Protection Act, if you looked through it, its aim was to protect, conserve, to rehabilitate, to improve the environment that we live in, to make sure that pollution is controlled and sustainable development is being promoted. And within this law, priorities were given to certain areas. Yes, Rafi?
Hello, Assalamualaikum. Ma'am, I just wanted to ask, so like, उसमें हमारे environmental act में तो सारा कुछ लिखा हुआ है कि we're against pollution and air pollution. तो फिर like how do things like जब smog होती है तो कोई consequence नहीं हो रहा होता to और क्या कहते हैं जब air pollution through old vehicles जो हम चलाते रहते हैं वो हो रही होती है तो फिर कोई consequence नहीं होता.
Yeah, I mean, it goes back to the question of ethics, which is why I think in this particular field, we need to be looking at so many things into account. When I was doing, I don't know if I mentioned it before, when I was doing my internship with the Environmental Protection Agency in Islamabad, they were telling us stories about how when they went for, they basically go for monitoring and sort of invigilation and see that they're abiding by the laws. When they used to go to certain industry, whether that was as a result of a complaint or just a simple, visit, the industries would scare them off with bodyguards with guns. And the environment in Pakistan is degrading exactly why everything else in Pakistan is degrading. That we lack proper ethical and moral values to enforce something. Like there's corruption, there are other problems because we're not true, like we're not true to whatever we do, and we don't really have moral boundaries set. Like if you want to make money, how far do you want to go? Like, and we have no boundaries whatsoever. We want to go as far as possible. And I think the cause is the same as as it would be for any other issue in Pakistan. Now there are polluter pay principles. Yes, Rafi?
Ma'am, can I add to your point?
Go ahead.
So, ma'am, you were talking about smog and like no steps were taken to curb the occurrence of smog. But recently there was a news that Punjab government has directed all the deputy commissioners to forbid the people from burning the remains of rice or wheat crops. But when they went there, the people resisted and they did not want to like abide by the law. So in the end, the authorities are trying whatever they can, but the people are not. They resist and they are not willing to change. So there is a lack of basic ethics in our society. So yeah, authorities are doing
It's such a
as much
multi-tiered
as
problem, right? For example, if I say that now there exists a law and that law needs to be enforced, and like we said, both of us said, the law is being enforced, so they're doing what they can, which is going on visits, and then people are not ready to adopt it. And when people don't adopt it, you think, do we need to go back to basic education and go and educate them? And then sometimes you would educate them and they would still not follow it. What do you do then? Do you penalize them? Do you ask them to stop certain activities? Would they get away with it? There are industries that get away with polluting the environment because they belong to someone more powerful, or they belong to someone who knows someone powerful who can still run their mills for them, right? But all of this law exists and keeps upgrading precisely to make sure that everything goes stringent and actions are taken. As far as smog is concerned, Rafi, I think a lot has happened. Like there was a lot of news coverage. People were being encouraged to not burn, for example, their crop residues. People were encouraged to not openly burn waste. People were encouraged to for example, carpool, travel public, and the cars, the discouraged individual use of cars. The government has now, like I said in the previous lecture, it has allowed for electric vehicles, or certain regulations have come into place. And I think some faculty from the SSC are involved in the policy that came for electric vehicles. So all of that is happening. And because, like I said, one of the prime reasons for it is the vehicular emission. So let's say if 50% of the vehicles or 10, 20% of the vehicles switch to electrical, how much would it improve? It would improve a lot. But you know, like I said, it's a question of morality as well as science, that they both have to be enacted at the same time, and not that you switch off one and switch on another and then switch off the one and go to the next. So yeah, but that's again a never-ending debate as well. So in PIPA, or the Pakistan Environmental Protection Act, a few things took place, and because hazardous substances were talked about, the control was talked about, regulation of motor vehicles, because we know, you know, a lot of fossil fuels are released, or a lot of NOxes, carbon oxides, and SOxes are released from engines or vehicles. So such regulations did come in, and they were important. They improved the situation a little bit. And even if, for example, in Islamabad, they did a thorough vehicular emission testing throughout the city. And I think the only vehicles that did not comply to the standards were the old buses of some government universities, but the government universities did not have the budget to change those buses. And so they could not change those buses in Islamabad. In fact, they asked for the universities to do it, but they couldn't fund it, and that's why they continued to use it. But a promise was made that those vehicles would be shifted slowly as budget comes in. So at least the presence of these laws, or the presence of these sections, encourages the institution or the EPA to go and do certain assessment measures, as well as implement or penalize a certain body who's not following it. Yes, Iman.
The laws are made by the government, right, so that the people can actually become more environmentally aware, right? But what about things which the government does which are really harmful towards the environment? For example, like the construction of so many roads and underpasses that leads to so much deforestation. So like, shouldn't the government also be held accountable for all of this?
So when cases like these happen, and under the PIPA, there are a few other things that need to be, that I should mention at least here, which is such as things like the environmental tribunals. The environmental tribunals kind of take cases. So the government can complain against somebody. So for example, the government can complain against a powerful industry, and an individual, normal citizen, like Shaila Zia did, could complain against any government agency. And I think I should mention the environmental impact assessment here, which came under the Section 12 of the Pakistan Environmental Protection Act, where before any development project, and memorize it, remember it, because in future, any development project that takes place in your vicinity, it's meant to have either an initial environmental examination or environmental impact assessment, where before I even put an industry, if I am the government, before I even start a road project or a highway project, I produce a report that tells me what is the baseline, how is this project going to impact the environment, the wildlife, the social life, everything. It is like a strategic document that tells you about the impacts that the project could cause, and how they would mitigate it, and how they would mitigate it not only in the construction phase but in the operation phase as well. And those are a public, they fall under the public domain. And those, which means that every time there is a project, I will advertise as the government that this highway is happening. I will prepare this environmental impact assessment document. I will send it to different academics. I'll submit it to the EPA. They will give their reviews. After that, the public hearing will take place, where all the public will sit and comment on it. And if they have any problems, all of that would be inculcated into the report, and the report will be updated with time. And once the document is ready, and once the EPA gives the approval, only then can you run a particular project. But how many of us know about this system, right? It only exists in a small bubble where a few academics get the report, they review it and send it, and they also do it out of basic courtesy because there's no money in it. So the EPAs have the connection with respective academics. They send it to the academics, they give their remarks. The public hearing is not very public, so only a selective set of people or some environmental activists make it there. And it's the same poor implementation of law in the case of IE and EIA as it is for any other thing And initial environmental examination is for smaller projects, EIA is for bigger projects. So let's say if there was a big housing society being built, they should have, wherever you're living, if there's a housing society that's being built, they should definitely do an EIA of the project. I have personally, as a part of the EPA, monitored the environmental impact assessment of the Centaurus building, which, if you know, is in Islamabad. It's like a huge shopping mall, as well as the Behria town in Islamabad. So I went for their monitoring. So when they said that they will take care of their solid waste in a certain way, and the wastewater will be collected in a certain way, and all the rest, we went for the monitoring in the construction phase, which is when I was working as an intern with them. Hamza, you have a question?
Yes, ma'am. I have a comment regarding the Centaurus building.
Go ahead.
Did you do assessment regarding their construction as well?
I didn't actually, because when I went there, I interned for 2 months, only as a part of my degree. And during those 2 months, I was doing basically the EIA survey on, if they've said that dust would be controlled and noise would be controlled, is it under control? Are people who are working on site wearing all the safety gears like hats and everything? So it was a very basic.
Yeah, like when I have a very interesting story. Like when the construction was happening, we drove by it, and it was dug very deep, and all of the trees that were cut down, that they were on the side of the road. So a very a thunderstorm came, they were high winds. So when we were passing by, and the logs of the trees were flying in the air, and one of the logs just bashed into our car as well.
Oh dear, yeah.
So yeah, so I remember that.
Yeah, and I think they also, when they designed the project, because they spent a lot of money. So when you're saying that they dug really deep, because they wanted it to be really high rise, and their initial plan that I had seen, which was still there when it was under construction, was to have like a helipad and I don't know what on top of it, and it was very fancy, much fancier than it is now. That came down, or was narrowed down after the public hearing and after the laws, because I think it didn't fall under how much height was allowed or how many stories were. So a lot of stories were actually cut down. The roof wasn't allowed to be open, and a lot of other things happened, which was a part of the process of EIA. Okay, so I just shared the environmental tribunal body, like what do they do, how do they fine, etc. But it's for you to go home and read. And now we come to the National Environmental Quality Standards. So someone said that although NEQs were mentioned, there wasn't a great detail on NEQs. Everything that's mentioned in the Pakistan Environmental Protection Act, it has a different document that supports or a different document that elaborates on it. And for NEQs, it's again another regulation that came in 2000, which has updated the standards for effluents, for air emissions, for vehicular emissions, etc. And this one, the one that I'm sharing now, is just for municipal and industrial liquid effluents. And that's why the units would be milligrams per liter. So I think it's very obvious. It's in milligrams in 1 liter. And that's what's shown here. I mean, you don't need to memorize it, but a sense of understanding of what each parameter means and what impact could it create on a water body that it would enter would be nice. And this goes for everyone. So for example, we mentioned things like TSS, right? We, in the hydrosphere or in the discussion on hydrosphere, we said that even sand and sediments are a water pollutant because they reduce the visibility of the water, or because they don't render it colorless, and that's why the photosynthetic activity would be decreased. But also it would be harmful for the life that's living and breathing in there. And similarly, grease and oil is it's more important because when it forms that sheen, that thin sheen over the water, it stops for the sunlight to pass through because it changes the angle of incidence. So those who know more about how the angles of incidence and reflections change, when there is something over water, especially oil, would know that it stops the process of photosynthesis, or it hampers it. But in the wastewater treatment, especially, it's important because it doesn't allow for proper degradation of wastewater, because it renders it's very hard to break. First of all, those who know chemistry would know that they're generally harder to break compared to many other chemicals. But when they're present in a water body, it's difficult to degrade them because they make the conditions anoxic, again by forming those layers, again by containing everything that's within. We've studied hydrogen cyanide, and that how it's a gas that's not healthy for you. And then cyanide in the effluent would be unhealthy for life that would face it. Sulfates, phosphates, we studied again in the hydrosphere related discussion that they could form algal blooms or provide those nutrients that form the algal blooms again above a water body, which impacts life below water. And then all of these other parameters, I think that in the next lecture we're going to discuss everything in a greater detail, because I just realized that you should know this more than the generic discussion. But let's have some very basic discussions on some of the very basic parameters that I just mentioned. Temperature. I think it's obvious. You know what temperature is, you know what the units for temperature are, but would you just guess what an increase or decrease in temperature would do to a water body? Anybody? And I'm saying guess. Fateh wants to guess.
Hear me?
Say it again.
Can you hear me?
Yes, I
can. You hear me? Yes. So, well, I'm no biologist, but well, what I think is, I remember reading back during the O levels something about enzymes which speed up reactions inside the body, but these only occur at fixed temperatures inside these organisms. So if the temperature of the water body rises, I mean, like by, like, shall we say, 4 or 5 degrees Celsius, then that would start to affect the temperature of organisms inside the water body. Then and then their chemical reactions inside wouldn't work, and they'd start to die.
Yeah. So a very basic result would be that change in temperature would decrease the functioning of the body. Why do even we dehydrate and die when temperature increases? Because our cells cannot deal with it. They cannot cool down quickly, and suddenly, we just pass out and die. But something similar, something along those lines. And yes, that's one good explanation of why increase in temperature would affect life below water. Hassan, you raised your hand.
One of the things that I thought of was, if there are pollutants in the water and the temperature increases, you would have greater evaporation of water. So the greater evaporation of water would then increase the concentration of the pollutants that are in the water. Additionally, it would also change the how much of the pollutant can be dissolved in the first place. But things like eutrophication would have a greater effect because you have less water and a greater amount of pollutant.
Exactly. So yeah, like a lot of things are happening, right? The greater temperature might increase growth of one kind of life, mostly it's algae or even fungus, because fungus grows at higher temperature. So what if the increase in temperature increases their growth and impacts growth of everything else that's there? Manil, you also raised your hand. I want you to speak as well.
So I was thinking about convection currents and how an increase in temperature could result in that being disrupted. So I was also thinking about the El Nino effect.
Yeah.
The fact that the entire sort of, I think the water becomes warmer, and that also changes the direction of the wind.
Yeah.
So that could possibly have an effect.
Yeah, that's a very, guys, you know a lot of science. Why do you keep giving me, implying that you know very little science? You guys know very good science. So I'm confident that the future lectures can be slightly more complicated than this. That's exactly what happens. Azhan, you have a point? Quick one, because I have.
Yes, so like I would like to add, so increase in temperature definitely increase the kinetic energy of the molecule, so the molecule can escape from the solvent, like so that's the main reason that the solubility decreases. Solubility of gas decreases as temperature increases.
Yeah, and also sometimes the salinity, the electrical conductivity increases because of the same fact. Like, so if there are salts, the kinetic energy would change that as well. So a lot of things change, although we think that a change in temperature would only mean, oh, it's too warm for me, but it's actually doing a lot of other things with the planet. And they're all the explanations that you've given are absolutely correct. I'm glad that someone mentioned convection, conduction, convection, radiation are also something which I wanted you to look at in the discussion on flow of energy, of how energy flows. So if it's not being conducted from one part to the other, how does it convect from the warmer part to the colder part? And how does that change the atmosphere above it? And how does it change the composition of atmosphere above it? But let's say we're talking about a small water body, and we're talking about me adding warm water into it. What happens when you add warm water into it is that the dissolved oxygen increases, and it's for the same reason that Azhan said, that it's easy for the gases to escape, or let's say the free oxygen would not be available as it is generally in water, and that's because it continuously interacts with air, or the air continuously enters, or at times because there's life there, or the plants there which photosynthesize and release oxygen. But when the temperature increases, that dissolved oxygen content, or the DO content, comes down. And when the dissolved oxygen concentration comes down, the life there would automatically suffocate and eventually die. And it changes with time. And like some of us said, that temperature is related to every other parameter, not just DO, but how the pH changes, how the metabolic rate, or the rate at which things grow, changes. And someone rightly said, Hassan, I think, said that it would increase eutrophication, again, something that we had studied in the hydrosphere. So all of that are expedited by simple thing, light temperature. Now we studied, everybody knows what pH is. Who from the social sciences can explain what pH is and how does it change? Okay, let me ask Nadia then.
Me?
Yeah.
Okay. So pH is basically the concentration of H plus ions in any mixture. So whenever a pH, so there is a scale between, that ranges from 0 to 14. So the pH says acidic, neutral, and basic. So whenever the concentration level is between 0 to 7, it's acidic, and when it is 7, it's neutral, that is our water, and when it increases from 7 up to 14, it is basic or alkaline.
Yeah. And how do you think, how can someone else explain, how do you think does that change the environment in a water body or even soil? Remember we said something about soil and soil, acidic rains on soil, and what do they do? Can anyone think about it? And again, it can be a guess. I'm not testing you guys. In hands. Okay, so let's just quickly say, for example, when we were looking at Taj Mahal, we said how acid rain was going to take the lime away and impact or corrode the surface of that building. In a water body, it could have another impact, like I was talking about soil. So in the lithosphere, if acidic rain goes down onto the soil, it will have a similar impact, which is that these soil chemicals will leach out of the soil into and travel, take away a lot of chemicals with it, and that they could be the nutrients that are required for proper growth of the plants. So that's another impact that an acid rain or an increased pH could have. But we studied carbon cycle and nitrogen cycle And just so you know, there are things that happen in those cycles where a pH of a certain body changes because of their activities. For example, we said that oceans are a sink to carbon dioxide, that carbon dioxide diffuses into the ocean and then goes back into the atmosphere because its concentration is higher at one place and lower at the other. Now, that could result in the formation of carbonic acid, which although is not a very stable, so it's a reversible reaction where carbonic acid is being formed and then it's being converted into water and carbon dioxide. So it's simultaneously happening in the body. But what that does is, of course, it changes the pH of the water. Carbonic acid is a weak acid, but it's still an acid, and it would change the pH of the water body. So let's say there's a lot of carbon dioxide going into the water body, then your satellite monitoring it from above could show you that the water is becoming more acidic. Sometimes it's because of the pollutants that are coming in, or a pollution in the form of carbon that's coming in. Sometimes it's pollutant in the form of higher temperature that's coming in that could change this equation. But eventually, that divides and that gives you that extra hydrogen ion, as Nadia said, which would increase the pH of the water body, and a lot of things around it would change, because like we said, with change in temperature, things change for life in the body. With change in pH, things change in life underwater as well. And the next one is for nitrogen. How do you think nitrogen, what happens to nitrogen when it reacts with water? And nitrogen, by nitrogen, I mean ammonia. Azhan, where are you? Paul? Anyone, actually anyone, not just the chemists, because I know now that all of you know enough science. Okay, Nadia, go ahead.
Ma'am, so when NH3 combines with H2O, it basically forms ammonia and it gives off OH negative. So OH negative is basically an indication that shows the environment is actually basic. So when it creates a basic environment.
So when ammonium is formed and hydroxyl ions are there, now at a normal temperature, at the normal temperature of water or at lower temperatures, this being formed is fine. You know, it doesn't do anything for the body, even if it increases the pH, especially in water bodies where a higher pH is all right. I will show some pictures of life that exists at higher pH under water body. But if pH increases, let's say it's not neutral or in the lower range, and if it increases above 9, the same equation reverses. Now, NH3 is very toxic for the fishes. It does a lot of damage to their gills, their skins, their breathing, etc. And because at higher pH this becomes reversible, now the reason could be anything, right? It could just be because of the fact that there are more OH ions, or it could be because of the fact that let's say a lot of an industry had put a lot of basic solutions into a water body. That would then result for NH3 to be formed, which is toxic to the life there. And if you just look at this graph where the atmospheric carbon's being shown, it also shows you that when the carbon dioxide, let's say for a particular body now, when the carbon dioxide increases for a particular water body, it's CO2. It's when CO2 increases, its pH would decrease, and that decrease in pH would change the quality of water. So the reason why I put it here was that when I'd spoken about the cycles to you, I had told you to look beyond the ordinary cycles. I told you to also dig deeper into smaller reactions that are happening around us, in the water that we drink, in the life that we breathe, to the oceans that we go to and chill, or to the rivers that we go to and watch. What is going on that is a part of this cycle? How is everything changing that then changes the acidity or basicity of water, and how does that change in the acidity and basicity eventually impact the life underwater? Because eventually that's more important for us. Yes, Daniel?
I didn't understand, does this equation reverse at higher pH or higher temperatures?
this equation reverses at higher pH. So at lower pH and at neutral pHs, this equation would mostly go in the forward direction, which means NH4 would be formed. But when the pH is higher, then NH4 would go back to NH3, which in higher forms is at a higher concentration is toxic for life below water. Okay. Okay, now pH has another very important role to play in, and I've shown you a simple, because the discussion was going around carbon, and carbonic acid, I've just presented this graph. But in general, for a lot of pollutants, there are certain, so for example, chromium at one form is more toxic than chromium at another. And that is very important for the environmental impacts of pollutants. And maybe we can discuss that in greater detail when we speak about pollution. But here, I just wanted to again show how when pH changes, the ions that are present in a water body change. And just don't forget this equation, right? That carbon dioxide and water form this can then degrade into it, and then finally into this. But through this process, as well as in general, through a change in pH, those ions and their concentrations could change. So let's say at a lower pH, carbon dioxide is dominant, but as soon as the pH goes above 6, carbon dioxide concentrations go down, and the CO3 increases. They're all interlinked. So basically what I want you to remember is that it's not just the fact that the presence of these species would change the pH, but when the pH changes, a presence of one species is more dominant than the other. And sometimes, for example, if this makes the soil more alkaline, and alkalinity is not suitable for life that lives in that water atmosphere, then this has become an environmental nuisance, right? And that increase in carbon dioxide, which eventually leads for increase of this, could also be because of human influence on the environment. We'll look at this in more detail in the other parts, especially when we talk about heavy metals or other ions and their electronic states or their isotopes, and how one isotope is more dangerous than the other. But also the fact that the change in pH would change the presence of a certain species, or the presence of a certain species would change the pH. Yes, Nadia.
Ma'am, does the presence of CO3 to minus indicates that the environment is more acidic?
Yeah, because it's carbonate, right? It's more alkaline, sorry. Because if you look at it, it's increasing at 6. And we said that the HCO3, because of the presence of hydrogen ion, would show more acidity, more lower pHs. But as soon as the pH goes high or above 7, it would decrease. Or you could interpret it the other way around as well, that as soon as its concentration decreases, the pH also decreases. That is, the HCO3 concentration goes down, and then the pH increases, or alkalinity increases. But when it's more acidic, then HCO3 is dominant. But when it's basic, HCO3 concentration goes down. And the activity could be just simple natural activity, which is presence of carbon dioxide into the atmosphere, or it could be an industrial activity that results in this. Right, now another thing that we mentioned, especially with reference to salt, was salinity or electrical conductivity. So when salts are present, or I said that generally the salts would go down with the soil, but when the water table comes up, the salts just remain there. We said that the oceans contain more salts. We cannot drink them because the salt concentration is higher in the oceans. So we've been discussing salts. Why is it so important for us to know what kind of environment exists in the natural setup? Every time we have, let's say, a salt concentration in a water body, it would increase the electrical conductivity or change the electrical conductivity, meaning that it would make it more conductive for the electricity to flow or the electron to pass through. And that results in a change in environment for the species that live there. Sometimes the presence of a lot of ions makes it difficult for animals to survive. But there are naturally species present in the environment that can survive at a higher salt concentration. And they're called halophilic or salt loving. And some of the species that you see here, such as tuna, lobster, they're all found in the ocean and they are present at higher salt concentration. And there are others that live in the ocean but breed in the fresh water. And I think this is where that concept of why estuaries are important and why wetlands are important comes, where a particular life under the ocean or a particular life in seawater would go to a freshwater body to make sure it breeds there or it lays their eggs there, and then comes back and the adult would live in a more salty environment. And some fishes, like if you're from the north and you've heard a lot about trout, it lives there because it requires higher dissolved oxygen. We just discussed dissolved oxygen. So for example, if you look here, trout is one of those species that requires higher dissolved oxygen in the water body for its survival. So if you bring it to a slightly polluted water in the city, it would not survive because it requires higher oxygen to be able to breathe properly. But then there are other fish forms, such as mussel or perch, that would just do all right at a lower level of dissolved oxygen as well. And then that life that we were talking about, they also interchange in the kind of environments that they live. So when we said that species are able to adapt, there are species that would naturally live under the ocean or in a salt condition or under high salt concentrations. They would be able to do that. There would be some species that would need to go to a freshwater body, or they would need to come to the surface because they require oxygen or because they need to feed or because they need to breed. And then there would be some species that would absolutely not survive in a salt body. So those species, for example, fish species that are found in the fresh bodies would be higher at some point, and then there could be other species. For example, as the salinity increases, the freshwater species would just go down and the marine species would increase. So the environment changes, and by environment, I mean the hydrosphere chemical conditions change or the salinity changes. That could result in a change in dissolved oxygen. That could be related to change in temperature of a water body, but all of that decides what kind of life lives there. And a life that has adapted to living in a certain condition would not be able to live that well in another environmental condition. And I think that's something that you need to remember. Now, TSS and TDS, or total dissolved solids and total suspended solids, are another important component when we talk about water quality or generally treatment of water or treatment of wastewater, because the suspended solids are suspended. You can see them. Like they're in the form of sand, gravel, grit, whatever you call it, it's visible to you. You need to take it off. So you could simply just filter it and take the suspended solid out, but it depends on the size of it. So maybe you need a microfiltration to take them out. But if they're bigger size, maybe just a cloth filter would work. But dissolved solids are tricky. Dissolved solids are dissolved in it. They are much smaller in size, maybe 2 microns and less. And that's why they're not suspended. You cannot take them out using even microfiltration. So you need to boil it. You need to heat it to make sure that it separates from the water body. Now, why is this important in the context of the environment? We said that if there's more silt, if there's more grit, it would impact the life in the sea. We said that it will not allow the light to pass through. But also when there is high flooding, again, the similar things that we said with reference to soil, that the soil has a pH which is slightly high, but if acid rain happens and the pH is changed, Acids have the ability to leach the chemicals with them. So let's say they take the chemicals away with them, the soil becomes deserted, and that's why the soil could face droughts in future. Now, these are all very interlinked with each other. Now, similarly, if you look at the, and you could also think of simple rain happening, the rain taking all the salts with it from the soil, and when it enters a particular water body, this conductivity of water could change. And the conductivity, again, simply is conductivity as well as salinity. They're kind of interlinked with each other, where the presence of salt could increase the conductivity of water, and similarly presence of dissolved solids could increase the conductivity of water. So they're kind of related to each other. But one thing expedites another. And you wouldn't think about this in general when you look at soil and when rains happen, and depending on what's the pH of the rain, you wouldn't care too much about the quality of the soil. But it does impact the quality of the soil, and it impacts the quality of water in return. So if there is more water, more flooding, and it takes away a lot of the soluble soils or organic minerals from the rocks, etc., with it, and it takes it away, its conductivity would increase because it has now dissolved in it a lot of things that are present in the environment, in the soil or above rocks or whatever that you can think of. Now I'm taking you back to an image that I had shared in the hydrosphere about how a point source of pollution could change the chemical and biological properties of a water body. And that's where we discussed dissolved oxygen and biological oxygen demand for the first time. Which one of you here can just tell me what's going on here? Because I've already discussed it. Same people, same hands. Yes, Rafi.
Okay, so as far as I remember, इसमें ये हो रहा था कि normal clean water में तो you have like मतलब a lot of dissolved oxygen, फिर उसके बाद point source से आगे जब pollutants शुरू हो जाते हैं तो फिर आपका dissolved oxygen कम होने लग जाता है. तो फिर इसलिए उधर जो क्या कहते हैं creatures हैं वो ज़्यादा anaerobic creatures को की life को support करता है, और aerobic creatures जो होते हैं like fish वगैरह उनके लिए मतलब मसला हो जाता है.
बिल्कुल ठीक. अदीन, आप भी कुछ कहना चाह रहे हो?
मैम, I had a similar answer कि जो point source होती है उस वहाँ पे क्योंकि ज़्यादा ये ऑक्सीजन जो है वो जैसे जैसे आगे मतलब थोड़ा point source से दूर होते थोड़ा आगे होते जाते तो मतलब थोड़ा ऑक्सीजन पानी में बढ़ता है ऑक्सीजन और वो फिर
अदीन, आपकी आवाज कट रही है, but I could understand it in bits and pieces. पहले ऑक्सीजन एटमॉस्फेयर में था, डिफ्यूज हो रहा था, सिंपल फोटोसिंथेसिस ओशन में या वाटर बॉडी में हो रही थी, ऑक्सीजन अवेलेबल था, डिसॉल्व्ड ऑक्सीजन बहुत ज़्यादा था, इसलिए एनिमल्स भी खुश थे, प्लांट्स भी खुश थे, और हेल्थ भी उसकी बहुत अच्छी थी. फिर जो ही वो चेंज हुआ, क्योंकि एक पोल्यूटेंट एंटर हुआ, उसकी वजह से कलर, ऑर्डर, हर चीज़ चेंज हो गई उस लाइफ के लिए जो कि उसके नीचे मौजूद थी. तो पहले क्योंकि ऑक्सीजन ज़्यादा था, इसलिए बायोलॉजिकल ऑक्सीजन डिमांड कम थी, क्योंकि उनको वो मिल रही थी, तो वो डिमांड इतनी ज़्यादा नहीं थी. पर जो ही ये पोल्यूटेंट सोर्स ऐड हुआ, बायोलॉजिकल ऑक्सीजन डिमांड बढ़ गई, क्योंकि डिसॉल्व्ड ऑक्सीजन कम हुई. और डिसॉल्व्ड ऑक्सीजन कई वजूहात से कम हो सकती है, जैसे हमने देखा कि टेम्परेचर में चेंज हो सकता है, कोई केमिकल ऐड हो सकता है जिसकी वजह से वो ऑक्सीजन के साथ रिएक्ट करें और वो उसको अनअवेलेबल फॉर्म में ले आएँ. तो बहुत कुछ होने के बाद अब जो है बायोलॉजिकल ऑक्सीजन डिमांड बहुत ज़्यादा हो गई, क्योंकि डिसॉल्व्ड ऑक्सीजन बहुत कम हुई. और अगर डिसॉल्व्ड ऑक्सीजन ज़्यादा होती तो शायद बीओडी में इतना फ़र्क नहीं आता. लेकिन अब बहुत कुछ चेंज होने के बाद शायद फिर बाद में वाटर बॉडी फिर, क्योंकि वो टर्न्स देके जाती है, उसकी एयर के साथ मुसलसल इंटरेक्शन होती है, डिफ्यूजन हो रही होती है, डाइल्यूशन हो रही होती है, शायद इस वजह से वो फिर जाके एक ख़ास क्लीन जोन में फिर से रिकवर करे. लेकिन जनरली एक पॉइंट सोर्स का इम्पैक्ट और फिर उसका इम्पैक्ट ऑन डिमांड ऑफ ऑक्सीजन मैं आपको दोबारा से एक बार एक्सप्लेन करना चाह रही थी विद द सेम डायग्राम. तब भी मैंने आपको सीओडी मेंशन किया था. जी अदी.
Yes, ma'am.
Your voice is still breaking, or maybe it's my computer. I don't know. It's still breaking. Maybe you can write it because I'm reading chats today.
Am I audible now?
Come again?
Yeah, I'll write it in the chat box.
Yeah, just write it in the chat box because then I and everyone else would be able to read it. But the one thing that I did not mention there was the chemical oxygen demand. Now, chemical oxygen demand is on top of the biological oxygen demand because it's not only the demand in the form of carbon, but also nitrogen and all the other life, and not just the degradable one, the one that's need for biota or life, but also the one that is not available, that is not in available form. So all kinds of chemicals that would need oxygen to degrade would come under COD. And the biological oxygen demand, plus which is needed by life, and the chemicals that need oxygen and are not a part of this BOD, all of that together makes the chemical oxygen demand. So chemical oxygen demand is sort of an addition of not only just the organic pollution, but also other form of inorganic pollutants that are not available for microorganisms or other life forms to be degraded. And if this is not clear, we can discuss it, and we should discuss it because you should know it. This is again something that I wanted to wanted you guys to know. I know all of you've gone through, and I'm in the safety committee, so I know you've gone through presentations that have told you what are the signs for different kinds of chemicals. And you should, at any cost, know this because you are students of this course and you should know what each sign means. But of more importance to you would be maybe the poison, the ionizing radiation that we just spoke about in the electric radiation, the biohazard, the carcinogens, the non-ionizing, and other things like corrosive or flammable and oxidizable, etc., etc. So these are signs that I think everyone should know in their lives. I wanted to discuss persistent organic pollutants. We've mentioned DDT before, and we've told that it's accumulates in life. Yes, Hassan.
Miss, why would the non-ionizing radiation need a sign?
Yeah, that's a good point. I think generally because we're now becoming less communicable in our lives, people are very careful. I know people are not careful here, but people are very careful abroad. And if you only sit with someone who's conscious about intake of sugar, you would realize that why do they care about how much sugar is in there? They take care of every single sugar point that they take into in any food. So if a food doesn't really mention that it's sweet and they eat it and they find out, they get really offended because no one told them. So I think it's just for information to be clear. And sometimes, like we said, even the non-ionizing radiations being around you for a greater length of time could impact your well-being. And this is not a public health lecture, so I haven't focused a lot on that, but long-term exposure could impact you. And anyone who's walking in or is going to work there in a particular organization, in a particular setup, should be aware of it. They would be aware of it, but public information has become kind of a compulsion everywhere, especially abroad, where you have to put everything like discreet right there. And not only do they have to put it, they have to remind people continuously that signs have been put for you and for your notice, because a lot of cases and litigations happen there actually abroad, where they sue government organizations for why they weren't told what existed there. So for example, if someone's taking their child to a particular office and no one really mentioned it, they would be angry that no one's mentioned it. So just for things to be more discreet and everything to be, open and there for everyone, they have kind of brought everything in a form. Yeah. So yeah, persistent organic pollutants, again, there's a Stockholm Convention. We spoke about long range air pollutants when we're talking about the laws relating to that. But POPs have become a problem in Pakistan because we used a lot of them. They were cheap, we used a lot of them, and they still exist in our environment, even though most of them have been banned. And UN DP, I think, is working very extensively on this in Pakistan. So I just thought I would mention it. The broader term for these is dioxins. Dioxins, again, are something which you might have read in relation to burning of plastic. So not only does it come from plastics, but also from the pesticides. And POPs means persistent organic pollutants. Because they're persistent, they stay longer in the environment. This was a name that was given to a set of chemicals which stay in the environment for a longer time, are hard to degrade, can travel longer distances with the earth elements, and can cause a lot of health impacts, and are very carcinogenic and have other problems. I think I will leave this for you in your home task. I discussed IE and EIS. This particular website would tell you what projects need an initial environmental examination and what kind of projects need an environmental impact assessment, and how that would fall under Schedule 1 or 2, and what would be the scale of it. So for example, if I haven't put all of it here, but for example, if you are talking about a hydroelectric power plant, if it produces electricity above 50 megawatt, you would have to submit, or if I'm proposing it, I would have to submit an EIA for it. But if it's just under 50 megawatt, a smaller setup, I can submit an IEE, or initial environmental examination report, to the Environmental Protection Agency and be done if I get the approval. It's like a big process, but it's defined very clearly where does each project go, and how to take it forward, how to take a development project forward. I think we are done. You can just read this at home. And if you don't have any other question, we can end the lecture here.
Allah Hafiz, ma'am.
I was so keen to say Allah Hafiz.
Allah Hafiz.
Allah Hafiz. I'm also very excited. Bye guys. Take care. Good
Thank
luck
you,
for
ma'am.
your mids and everything else.
Thank you. Allah Hafiz.
Yes, Adine?
Yes, ma'am, I will get.
I still can't hear you.